Merry Christmas, a Happy New Year, and this is our first video in the new year. It's been a while. So, in this video we are discussing and commenting on this article, creating ratio word problems. Exactly one particular type of ratio word problems with two equations which lead to a system of equations. Okay, so you can read this text. It's just a complementary thing, but I'll give you the gist. And in the first video we are creating ratio word problems of the type which I called mother-child age. Actually, the problem goes very easily, and by the way, why didn't it? Okay, I'll work on it. Let us consider this table. To create this problem, I just choose two variables. Say x is mother's age and y is son's age. So I just choose two numbers, and my first choice, which I didn't specify in the article, should be not very difficult. And to do that, you shouldn't think of choosing prime numbers. It's not a very good idea. Especially the bigger number, the mother's age, it's a good idea when they would, both numbers would have common divisors. But in this case it's very simple. Actually 9 divides 27, and so my choice is 27 is mother's age this year, and 9 is the son's age this year. Then I calculate the ratio. It's 27 to 9, which gives me 3 to 1. And then I skip some years ago, for example 3 years ago. My choice was driven by the fact that when I subtract 3 from both 27 and 9, I get nice numbers like 24 and 6, also a very easy ratio. And this produces my problem, which looks like this. Which looks like this. Here the only difference from the table is that I have chosen names for the mother. It's Sophie, and for her son it's Henry or Henri. And this is it. If we solve this problem, we have to produce a table like this. It would be Sophie, it would be Henry. We don't know their ages. We write X for Sophie and Y for Henry. And we can write now, we can write also ratio. And we don't know X and Y when we are solving the problem. We just write 3 to 1, which is specified in the problem itself. Then 3 years ago we have, of course, X minus 3 and Y minus 3 for the ages. And again, ratio 3 years ago, it is 4 to 1. And here we go, we write two equations. The first one is from this one, from this set of information. It gives us the first equation, which is x to y is 3 to 1. Or, as we mentioned many times and stressed many times, it is better to get used to more usual notations with a fraction line, with the usual look of the fraction. In this case, we get this one. And then the second equation, which is produced from two other columns. Oh, my voice. And here we go, x minus 3 to the ratio of x minus 3 to y minus 3 is equal to 4 to 1. Or again, I prefer this type, and it gives me 4 to 1. This is the system of equations, and we have to solve it. The first equation gives us, we crisscross, multiply. It gives us x is equal to 3y. And the second proportion gives us x minus 3 is equal to 4 times y minus 3. Then, in solving and going further, we don't change the first equation. But in the second one, we multiply out x minus 3 is equal to 4y minus 12. Then we just take the simplest equation and plug it into the one which is more difficult. The easiest way to plug is just to replace that x with what is equal to, in this case it's 3y. And we get a single equation for y. And then we just solve it. We see that it's easier for us to produce, to collect all the numbers on the left-hand side. So, to do that, first we add 12 to both sides of the equation in a usual way. And here our 12 cancels, negative 12 and positive 12 they cancel each other, and now we have this. Then we do the same with 3y. We, in this case, subtract 3y from both sides of our equation. And we can also calculate 12 minus 3, it gives us 9. 4y minus 3y. Here, 3y cancel each other. And finally, we arrive at 9 is equal to y. This is our answer exactly for y. Y is equal to 9. And then the only thing which remains to us is to plug it into the last remaining equation, which is x equals 3y, which gives me x equals 3 times 9, which is 27. This is the answer. We knew the answer beforehand, but I just wanted to remind about the way how we solve such problems. Are they that difficult? No, they're not actually, but on the other hand, it's an equation, a system of equations, which is in itself considered not very easy. And as I mentioned in my article, we don't have many such problems. We don't have enough such problems. And what we have to do is create them ourselves. But let us not stop here and create something else. For example, let's check other figures. Here I would take another table from my article, namely this one. This is a mathematical model for all such problems. And below I will just rewrite this table to something else. Let us make a mother again, and let us her name have, for example, Alice. Mother is Alice, so Alice. So this is the table, Alice. And the son's name, for example, Harry Potter, Harry. By the way, I think Lucy, then it should be Lucy. Of course, Lucy. Let it be about Harry Potter. Lucy, I remember that his mother's name, Harry Potter's mother's name, Lucy. And have no idea how old he was when he was born, how old she was. So I will just, for example, let us also take nice figures like, for example, 36 and 9. 36 and 9. She was definitely younger, but it's not. We're not heading towards historical accuracy. Speaking of history concerning Harry Potter, we can just they are magicians, so everything happens in that world. Okay, so I have chosen the ages, 36 for the mother and 9 for the son. That's all right. She had a son at 27. That's a normal age nowadays. So, so it would be now. Ratio. Now. 36 to 9, it's 41. Then, age, how many years ago? Let's take 6 years ago. 6 years ago. Again, it's a nice number. 36 minus 6 gets me 30, and 9 minus 6 gets me 3. So here is 30, here is 3. And the ratio is beautiful. It's just 10 to 1. And ratio. 6 years ago. So 30 to 3, it's 10 to 1. 10 to 1. Here is the problem. Here is the problem. I can now unleash my imagination in creating exact words, because I can word it differently. I can just give the ratio, or I can write something like that. This year, Lucy is 4 times older. 4 times older than her son, Harry. Six years ago, the ratio of their ages was 10 to 1. And now you can ask whatever, find their ages, or what is the sum over of their ages now, or what is the difference of their ages, which is the same. Of course, we understand that when the son was born, her mother his mother was a definite age, and then this difference stays on. It's an invariant. So there are so many possible variants to ask something. What did I ask in the first place? Find their ages this year. Okay, then let's find the difference. What is the difference of their ages? What is of their ages? That's it. If we produced a system of equations, again, two equations, we have two conditions, two equations, we would find 36 and 9. We won't do that again. So the difference is 36 minus 9. It is, what is it? 27. It is 27. So we know the answer. It's 27. And it remains the same. When we ask about the ages, we should specify at what time. For example, we could ask, we could have asked another question. For example, what will the ratio of their ages be in, for example, 10 years? And the answer would be, what would be the answer? 10 years from now, it's a good idea to, in 10 years, in 10 years, I think it's not necessary, 10 years from now. It would be 46, the answer would be 46 over 19. By the way, nothing even to cancel. So this is the answer, just not a very good fraction. So, and there are infinitely many ways to express this problem, to word this problem. Actually, you could put the other condition, the second condition, also in words, and saying that 6 years ago the mother was 10 times older than the son. Sounds frightening, but it's actually 10 times older. Sounds really frightening. But as you see, you can create any problem of this kind, going backwards, create easily, and then you can either solve it yourself or present it to your friends, or just, I think in our case, we'll be exchanging the problems. I will create problems for you, and you will create problems for me. I will enjoy reading them, because we have to be accurate. We have to be careful in not producing an ambiguity, because if we state something not clearly, then it's not a good idea. Anyway, this is it. The first part of the video is finished. And the second part will consider the second type of the problems when people exchange money with different purposes.